The doubly linked list is a linked data structure that is having set of sequentially linked records. That record is called node. Each node is having three different fields. That three fields are: one is data portion, and another one is address of previous node, and third one is address of next node. This previous and next pointers are reference pointers to the other nodes. Here the head and tail nodes denoting previous and next pointers, which is pointing to the terminator. Because terminator in the sense the head previous, okay, previous link of head node, and next field of tail node, both are representing the terminators means null value. Okay, it represents the null value, that means end of the list. Okay, so this is called, right, this is can be represented by using null, or one more approach is sentinel node, in the sense that sentinel node will have only two fields. One is next field, another one is previous field. It will not have the data field. So this node is called sentinel node. So we can represent in the horizontal way also. So here three fields will be there. The data portion, nothing will be available, so this is previous. The last field is next. So we can say in both ways. The traversal can be applied in both directions, that is forward and backward directions. Suppose if we are moving from head to uh, 20, okay, we can move forward by using the next field. At the same time, suppose if we are in the last node, okay, if we are in the last node, if I want to move backward, I can use the previous field. Okay, I can use the previous field to move backward in the doubly linked list. This is one of the main advantage of doubly linked list. So how to create the structure of the node in doubly linked list? So here we are having three fields: field number 1, field number 2, field number 3. So here the data is the value which is going to be assigned with different data types. So inside the node class, I am creating the data with some data types, primary data types. Then if you want any key to represent the node number, then we can use it, otherwise we can leave that. Then previous pointer, which is pointing the any one of the node, that's why we are using the node object. Then we are creating one more object, that is next, to point the node which is available next to this current node. Then we are calling the constructor to assign the value to the variable data. Right here, suppose if I am passing the value 10, then the node with 10 is created. Here 10 is assigned, then here both are null. Right, both are null. Previous field also null, next field also null for the new node. So this is the way to create the node in doubly linked list. What is the difference between doubly linked list and singly linked list? The advantage is we can traverse in both directions, forward and backward directions. But the sum of the operations here, it will take some more time. In the disadvantages, it look at that when you are manipulating the uh, node, it will, we have to change two fields, previous field and also next field, so it will take much time, and it needs more space comparing with singly linked list. Here the singly linked list is having only single address pointer, so this is also integer, right? So it needs some memory locations. When you are taking the doubly linked list, two fields are there, okay, two address fields are there, it will take more memory locations for address fields. That's why it is need of more address, I mean more memory space. But there is the possibility of moving backward and forward direction, so deletion and insertion is very easy comparing with single linked list, right? But here there is possibility of more errors because of we are having two links for each and every node. This is the difference between doubly linked list and singly linked list. Thank you.